My screen is visible, right? So
Yes.
today I prepare one topic, observabilities. Okay, observability, ability, observabilities or observabilities. So under the observabilities, we need to, for example, we have some servers, some production servers. Okay, we have some production servers, some Docker environments or Docker platform, then Kubernetes. Consider these are the infrastructure in our organization, okay, or that we manage. So, for each infrastructure, there is some application running. Okay, consider like that. So we need to monitor these infrastructure. Okay, for example, we have one Kubernetes cluster or two or three like that. Okay, so we need to monitor. We need to monitor these types of infrastructure. Okay, like Kubernetes or Docker or like virtual machines or any infrastructure. Okay, like database, some applications, specific application. So everything we need to monitor when coming to production. Okay. So monitoring is comes under the observabilities part. Okay. So we called as observabilities. So coming to observabilities, so there are lot of tools and services there to monitoring these types of infrastructure. So commonly, some open source tools are that we used Prometheus, then Grafana, then some other tools like Node Exporter, Node Exporter. So commonly in nowadays commonly used two tools is Prometheus and Grafana. So these are the open source software. Okay, these both are open source. So we can directly like install this application and integrate with our infrastructure. Okay, so we can easily monitoring our infrastructure using Prometheus and Grafana. So both are open source. So we didn't pay anything for this application. So similar paid application like Datadog. Datadog. This is one paid application, a web application actually. This is one. So we need to pay for this service. So similar way we can integrate the same things like we can integrate virtual machine to Datadog, Docker to Datadog, Kubernetes, or any infrastructure. Like even the accounts we can integrate with this Datadog. Okay, for example, we have AWS account. So we need to monitor the entire AWS account, or we need to add this entire AWS account to Datadog. So using Datadog, we can monitoring the services and everything. So this one is paid one, and these two, Prometheus and Grafana, is open source. So we can use as free. Okay. So anyone have a doubt
No doubt.
for the new members like Deepthi, Manasa, Monso?
No, sir. Actually, one of the recruiter asked me the question about a Datadog recently.
Yes, I included that Datadog in our in course structure. Okay, in coming section or after, yeah, I will take that. I will include that. Okay, that Datadog.
Okay, okay.
So yeah, basically we are using these tools for monitoring our infrastructure. Okay. So coming to Prometheus is a open source monitoring and alerting toolkit. Okay, it's a toolkit that is designed for reliability and scalability. So uh, coming to the working principle, the Prometheus scrapping the metrics from the various systems. Okay, system means we need to install the Prometheus to any system. Okay, so the Prometheus will scrapping the metrics. Okay, so scrapping the metrics from the machines and store them in a time series database and provide robust querying and alerting capability. So these are the core working principles of Prometheus. Then coming to Grafana, Grafana is similar way. It's a open source platform that is for monitoring and observability. So this Grafana provides a powerful visualization capabilities like for time series data or creating dashboard. So that will display data from various sources like Grafana. So these are Prometheus and Grafana is two tools. Okay, like for example, I will explain the workflow so you will get more idea. For example, I need to monitor one virtual machine. Okay, like a EC2. I launch one EC2. I launch one EC2. Okay, so we can utilize Amazon CloudWatch. That is Amazon services. That is CloudWatch. So we can utilize that service for monitoring our EC2 machine, or else we can go with the these types of open source softwares. Okay. So for example, I'm not going with the CloudWatch. Okay, I'm going with the Prometheus and Grafana. So after launching the EC2, then I need to configure the Prometheus. So install Prometheus. We can install this same EC2 machine, or we can install any other Prometheus, any other EC2, and we can call as Prometheus server like that. So after that, we need to integrate with the specific EC2 machine, like for example, this machine. Okay. So what will happen? The Prometheus will getting the data from this machine. Okay, the EC2 machine. Like what are things it will share, like CPU utilization, memory utilization, network, uh, like traffic. So some commons like resource we are monitoring. Okay, like similar way CPU, memory, like that. So everything will comes in this Prometheus. And after that, Prometheus doesn't have the, like feature to visualize these types of data. Okay. So visualization, we are using Grafana. But Grafana needs some source, okay, some data source. So in this case, Prometheus is one of the data source because Prometheus have all the details of our specific missions. Okay. In this case, it's EC2 mission, like virtual mission. So the Prometheus have that specific mission, CPU utilization, CPU, not CPU utilization, CPU, memory, and every data that belongs to this Prometheus. Okay. So next thing we need to configure Grafana. after that, here we need to add the data type or data source. Data source. So we need to select the data source is Prometheus. And we need to provide the Prometheus like IP or something like that when we configuring that part. So there is a connection between these Prometheus and Grafana. So here we can log into the Grafana dashboard and there we can see the visualization part of this specific EC2 machine. Like the CPU, total CPU we can see like this, and 60% utilization and 40% free like that. Similar way we can see RAM, storage, network, everything we can monitoring, okay, based on the specific machine. It's for a Docker, then same way we can use the same things. For example, next Kubernetes. We are mostly deploying Prometheus and Grafana for monitoring Kubernetes actually. So after configuring that Kubernetes or after like installing the Kubernetes cluster, we deploying applications, right? So after that, we need to monitoring this entire Kubernetes cluster. So there are a lot of tools are there. So most common tools like Prometheus and Grafana. So we can easily deploy these two things and we can monitor our Kubernetes cluster. So in this case, okay, coming to the EC2, one more service I missed, that is node port, okay. Node port. Sorry, node port, not node port, node exporter. It's a service that we use for getting the specific machines data like CPU, memory, metrics, like traffic, bandwidth, everything we can collect using a service called node exporter. So without a node exporter, we couldn't get that specific machine details to this Prometheus. So first we need to launch that EC2 machine. Then we need to install node exporter within that machine. Then we need to connect with the Prometheus and Grafana. Got it? All of you?
Yes.
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 So I will do one lab for Kubernetes monitoring. Okay. So how we will monitoring Kubernetes cluster. So for like coming to Kubernetes, we use one tool called Helm. Anyone heard about Helm? Helm.
Is it like a package manager for Kubernetes?
Yes. Helm is a package manager for Kubernetes that simplifies the deployment and management of application in Kubernetes cluster by using pre-configured chart. So coming to the pre-configured chart, that chart have the metadata like the API, You remember when we when we deploying application using Kubernetes, we need to write up the YAML file, right? So after that, we will apply the same YAML file, the declarative way, okay? So we need to create the YAML file, right? So if we use Helm package manager, then we didn't bother about that creating of YAML files, okay? Because all the files are in the package manager. The package manager means it's a collection of YAML files. So that YAML files most probably open source application like Prometheus and Grafana, Nginx. Lot of packages are there like YAML packages. So we can just simply running our application within our environment without YAML file. So that we use Helm package manager. So in this case, I will use Helm package manager, okay, for deploying Kubernetes and Grafana. So I am going to deploy Kubernetes first. I'm just adding my MFA for this account. Otherwise, I couldn't join. Okay. So how we will uh, install Kubernetes? So I will show you, okay, quickly. So I am taking one machine to manage the Kubernetes cluster. Local machine. Amazon Linux is fine. First, I'm launching one machine. Okay, uh, you can do it your own local machine. Okay, not deploying. I mean, launching any EC2 machine. For me, this mission, my personal, this is not my personal account. So some privilege issues are there. So the machine is running. So I am considering this machine is my as my local machine. Okay. So first I need to connect. All are following, right? Following me, right? So I need to install some services like kubectl, AWS CLI, then EKCTL. So these are the things that we need to install, okay, as a prerequisite. So I am copying the code and paste it here. Okay, fine. It's running. I mean the which one is this? Yeah, EKCTL. Okay. EKCTL is a tool that we install for managing uh, Elastic Kubernetes service in and AWS. Okay. Now I install kubectl. Kubectl is a command line tool to interact with the Kubernetes cluster. So, in this case, we are going to deploy like Kubernetes. So before we need to install the kubectl command. So next thing is I'm going to install Helm. Okay, because we are using Helm package manager to run or to deploy that Prometheus and Grafana. So this is the command to running Helm. So that will download the scripts actually, Helm scripts. Okay, it's successfully download. This is a version, Helm package manager version. So seems everything is running fine. So now I am going to configure a Kubernetes cluster using EKCTL. Okay. So this is a command EKCTL create one cluster. That cluster name should be test EKS. Then the region US East 1. The node group name, that is my nodes. Then the node type T3 small. The manager one. And the node count 2. Click. So here, see some permission issues are there. So we need to provide the permissions privilege to running because the EC2, this EC2 machines needs to create one other Amazon service, that is EKS. So we need to provide the corresponding roles and permission to this machine. Okay. So I already created one um, role and policies for the same, like creating Kubernetes cluster. So I'm just going and choose that role to this specific machine. That name EKS admin. Yeah. So now I'm going back and run the command again. ACTL cluster HTTP status error. Sometimes we face some error like the cloud formation error. Okay, so at that time, just to go and edit the name. Okay, name of the cluster. TT test 22. Now it's creating. It will take some time. So anyone have any doubt as of now? So we can discuss if you have any doubt or clarifications. All are good, right? So the new joiners deploy, configure EKs, right? Deepti, Manasa, Monsu.
I did it like a year ago. I don't know. Let me ask you, if I open an account, is it still valid, you think, or I have to create a new one? I haven't tried it yet. Like I had one.
You didn't have an account, right? AWS account.
I did open one like a year, almost 1.5 years ago.
Okay, can you check the login now? You have the accessibility to that account. Are you verified that?
Actually, hold on. I have to find where I have to write down some. Okay, I will check it. I'll let you know because
No.
I had to look for I forgot the password actually.
Mhm.
Uh, okay.
My account is active, Tawfiq.
It's active, right?
Yeah.
Okay, fine.
But
Did
my
that?
free tier will get over in a month, I guess. So yeah, I'll have to see that.
But you just deploying any infrastructure or an application. After that, you
Yeah,
will
yeah, yeah.
terminate
Yeah,
it.
yeah, that is happening. Yeah, no worries.
Okay. Because we are around 80%, we need to do the labs. Okay, the CACD labs or
Mm-hmm.
like these
Got
types of
it.
configuration. Right?
Got it.
So here you can see in backend the Amazon EKCTL and the CloudFormation creating Kubernetes cluster, that is Elastic Kubernetes cluster EKs for us. So Deepti faced the Datadog question or Manasa.
Uh, I'm only sir.
Yeah. What was that? I mean, the question.
They asked about the Datadog. Do you have any experience in Datadog? What is the use of Datadog? Like that they asked.
Oh, common questions, right?
Yes.
Did you respond or?
I said I don't have any experience in Datadog.
So now you got it by what is Datadog, right?
Yes, sir.
It's a monitoring web application tool, okay? So
Okay.
I already included that in our section. I didn't take that as of now. It's coming section, coming uh, day I will take, okay?
Okay, sir.
So you can just type Datadog and see this is the URL like datadoghq.com. So here we need to create a login. I mean, create an account. Click on login. So here we need to provide that organization credential or personal one. Then we can try free. Okay, like 14 days we can go through that Datadog and onboarding infrastructures, monitoring application, everything we can do for the free trial. Okay. So we didn't provide any debit card or anything. We can try it as free for 14 days. So we can use any Gmail account or anything and click login. Then after that, it will we will land in a like some dashboard. So there we can choose corresponding. For example, we need to monitoring. We have three servers. Okay, like one Windows server there or Windows virtual machine there and one Linux machine there and one Ubuntu machine there. Okay. So we need to install a agent, okay, a Datadog agent to the specific server. For example, to onboarding a Windows server or a Windows machine to Datadog, we need to install corresponding Windows agent for Datadog. We need to install on the specific Windows machine. For the same, onboarding a Linux machine, we need to install the Linux agent to that specific machine. Ubuntu same, Red Hat same, like that. So after installing the agent, that agent will, it's a API, like API code, okay. So the agent will communicating with that specific Datadog account. So it will, I mean, we can see that machine is onboarded in that Datadog account. So there's a lab. There is, I think, we in our lab, I will showcase how to onboard a virtual machine, like how to onboard the Docker like that. Okay, so you will get more idea. And after onboarding this infrastructure, we need to set up that alerting thing. Okay, for example, if any CPU exceeding a CPU utilization like above 80% or above 70%, the Datadog will send a mail to the concerned team or the monitoring team that informing like this specific server is utilizing above CPU utilization or above 80% or 90%. For example, one EC2 mission, like we onboarded one EC2 mission. So that mission is going to down or it's going to down. So at the same time, we will get a alert that is the machine is uh, like it's down or it's failed. So we can quickly go to that AWS account and troubleshoot the issues. So that's why we are using these types of monitoring tools in production environment. Got it.
Yes, sir.
Mhm. So in this lab, what are things that we are going to do? Now we installing Kubernetes cluster, okay? The entire cluster. We have I think two node we installing, right? Node 1, node 2. So we configure the E case, okay? Consider like that. Assume like that. We configure that this part like E case configuration. So after that, we need to monitoring this cluster. So in this lab, we will installing Prometheus plus Grafana. So what will happen? The Prometheus will getting the details of this specific cluster, and coming to Grafana, we need to configure Grafana and add the data source as this Prometheus. So the Prometheus have all the data, right, from the machine, or from the cluster. So here in Grafana, we can visualize the Kubernetes cluster. And to set up these two things, okay, installing these two things, we will use Helm package manager, Helm. So the Helm package manager have the like YAML file for this Prometheus and Grafana. So we can quickly or easily deploying both in our Kubernetes cluster. So actually we are installing the Prometheus and Grafana within the Kubernetes cluster. Got it?
Are Prometheus and Grafana on the same node in the Kubernetes cluster or different nodes?
Kubernetes cluster.
So it doesn't matter. Can they be on the same nodes or different node?
This is actually a Kubernetes deployment. So that might be going to node 1 or node 2. That is managed by that master product.
Okay.
The scheduler and everything there, right?
Okay. And the Datadog is also installed on Kubernetes cluster?
No. Datadog is a web application. We did not install anything, or we just log in and provide the credential things like that. After that, we need to take or copying the agent URL and paste it on the record servers. So the agent will run on the server and it will communicate with the Datadog account, the specific account that we created. So there is a API for a specific account. For example, Mahesh or Amol create one account each. Okay, so you both have different API codes or API. So you need to install the API to the specific server. So that servers know that is belongs to Amol's Datadog account or Mahesh Datadog account. So they will project in your Datadog account that machine's details and everything. Got it.
Can you repeat this last point? So there is a different people will have different logins to Datadog.
Yeah, I will. So Datadog is a web-based application. Okay, Datadog. It's a web application. Web app. So similar like Facebook or like Instagram. Okay. So Facebook we created a specific account, right? So similar way we go to Datadog and create one account. So the account name is Amol. So another person come and create one account. Okay, another account. That is Mahesh. So you both have your own API there. Okay, coming to your account, you can see a unique API for both for you. API code. Okay, it's a alphanumeric code. So so both account configured. Then next thing you need to configure your machine, right? So you have EC2 machine, EC2, EC2. Mahesh have another EC2, EC2. Okay. So we need to onboard this machine to your account. So what we'll do, this machine is Ubuntu, okay, consider Ubuntu. This machine is Windows. So Mahesh, go to the Windows option. There we can see in Datadog, we can see a lot of options there to onboarding different machines, different OS. So each machine, each specific machines have different agent. Okay. So you go to the Windows options and copy the agent or download the agent, or you will get the path, okay, to download the agent. So you need to log into the machine and download the agent for Windows case and provide some credentials, okay, like API or anything. So the machines communicate with the Mahesh account. So Ubuntu, coming to Ubuntu, you will Amal, go to the Ubuntu section on the Datadog, and you will get a URL. I think for Ubuntu machines, we will get some URLs, okay. That URLs have the URL for installing the Datadog agent, okay, like some curl command or the HTTP, everything is mentioned in that URL, and they will put the API, the unique API within that URL. You got it? So you installing that or you run that URL in this Ubuntu machine, that agents know this API belongs to Amal's account. So that machine comes in this account. Got it? Amal. So the cluster is ready. I'm checking the node. Okay, 2 node, everything is fine. So our cluster is ready, okay, up and running. Yeah, I'm all disconnect actually. Oops.
I'm sorry, I got cut from the meeting.
Oh,
You said that there are different API keys are there. So those keys you probably put in somewhere to connect Datadog to that specific application on the cluster. Is probably what you're about to
not
say.
application actually. For the machines actually, infrastructures like Kubernetes, Docker, or EC2 machines on-premise machines. Anything we can onboard in this Datadog. Application tools like even Apache, web servers we can monitor, Jenkins we can monitor. You got it.
But where do you put the API key on the? Is it like a key like
It's a URL actually. That URL have a API key, a specific API key, a unique API key. Because if anyone creating any Datadog account, they will get their specific unique API key. So that and we need to we use
so the key is in a text file. The key is in some text file.
It's a alphanumeric like 20,
But you
30.
you store it in a text file on some particular
No.
directory.
That is no. That is in between that URL actually. That API, specific API.
Okay. So it's in the URL, the API key.
Yes. That API included in the URL.
Okay.
Yeah.
Sorry, I disturbed your flow. I just wanted to tell you that I
No.
missed what you said and then I came back in.
So here you can see I installed successfully installed the EKS. Okay, so the node count, everything is listed here. So the next thing, using Helm package manager, we need to run that Prometheus and Garafana. So for that, we need to first add Helm stable charts in our local machine. So there is a command for that. So this is the command to download the Helm package manager charts to our local machine. That means the EC2 machine. Okay. So the stable has been added to your repository. Then we need to add Prometheus Helm repos. Okay. So there is another command to add the Prometheus Helm repos. So the Prometheus community has been added to your repository. It's fine. Then using Helm package manager, we can search that entire community-based packages, okay, within the cluster. Sorry, within the machine. So this is the Helm search command. Helm search repo Prometheus community. So these are the packages in Prometheus community. Okay, like Prometheus community alert manager, SNDP notifier, Jira alert. So we need to install one specific package manager in between this. That is, which one is that? Prometheus Windows Explorer. Yes, Prometheus community, Cube Prometheus. That's the one we are going to install. Cube Prometheus. So before that, I'm going to create a namespace. The namespace name is Prometheus within the Kubernetes cluster, okay? Not in that EC machine. I'm creating a namespace in Kubernetes cluster. Namespace created. So after that, I'm going to install that Helm install Helm package manager for Prometheus community, Cube Prometheus. That's the name of the stack, okay, like the package manager name. And that package manager will deploy within that specific namespace that we created now, that is Prometheus. So this is a command. So here you can see we use Helm for installing stable Helm install stable. So this is the package manager name, okay. And here we need to mention which namespace that we need to, deploy this specific application that we need to mention here. -n that for namespace. Then the namespace name from this that already we created here. See. So hit enter. Okay. So the status is deployed, everything is fine. Parent Prometheus using operator. Okay. So I need to check that because here now we install a Prometheus application within our Kubernetes cluster. So we can check using kubectl get pods names Prometheus. So it will display here. See, Everything is running and all are ready. Like all the containers are ready. I will check the SV services as well. Okay. See, you can see the services for Grafana. This is actually a combination of Prometheus and Grafana. Okay. So we didn't do it manually or one by one, like Prometheus. First, we need to install Prometheus, then Grafana. So that's a time-consuming process. So we can use LM. So it is very simple. Like, see, it's a combo or combination of these two services or applications. So within a simple command, like simple helm command, here you can see the deployment of this Prometheus and Grafana and the services. Everything is listed here. So coming to the services, see, as of now, all the type is cluster IP, right? So we need to change something to load balancer. So we need to access that thing like Grafana or Prometheus. So we need to change the service type actually. So these are services already installed, but we can edit the services, okay? So I am going to edit service to change cluster IP to load balancer for the like Prometheus, STA, Prometheus and Grafana. Yes, so this is the service configuration file, okay, that YAML file. So here you can see the type, the service type, that is cluster IP. So I'm going to change, type insert and change to load balancer.
Let's try to keep it up. Throw it at their chest, just like that. Like that. You want to try another one? And when I blow my just pass right to Matt here. It's going to be good. All right, Matt. You know what you're going to do. Ready? And then as you
When we typing the like service types, okay, so three types are there, like cluster IP, node port and load balancer. So the name conversion, like cluster IP, the C is capital and IP is capital, okay, the left of them are small. So coming to load balancer, we need to put L and B capital, left of them are in small letter. Otherwise, we will face error. Okay. So this is fine. Control X. Exit. WQ. So I edit one is someone services that is for table Q Prometheus, STA Prometheus. This one. Only change this one. Okay. Now I'm going to change the Grafana as well. Because these two things we need to take like we need to access. Okay. This is for the Grafana. So I'm changing the cluster IP to load balancer. Balancer. This is fine. Save and exit. now I am checking the services again, okay. See, for the stable Grafana, the like type changed to cluster IP to load balancer, and stable Prometheus is TA Prometheus, that is also changed load balancer to load balancer. So here we can see that URL, load balancer URL, okay, external IP. So we need to copy and paste it on our browser and hit enter. So this will open the Grafana dashboard or Dashana application login page. Okay. So after provide the initial login, we will landing to the Grafana dashboard. So this is the application that we installed in Kubernetes. Okay, that is Grafana. So before that, we need to check that Prometheus. Okay, we already installed Prometheus and exposed the Prometheus using cluster load balancer. So copy that IP, copy and paste it here. Enter. Sometimes we need to mention the port number as well for the Prometheus 9090. Okay, we can come back. So just now we are going to log into Grafana. So the Grafana default login ID admin, and the password is prom operator, prom dash operator. Yes, now we successfully log into Grafana dashboard. Okay. So this is a newly Grafana dashboard. So we need to onboard the required infrastructure. Okay. In this case, we need to onboard Kubernetes. So here you can see the plus button. Okay. 9090. That's all. 9090. Okay. So coming to Grafana, here you can see the plus button. Okay. So click on import dashboard or new dashboard. We need to create, if you need to create new dashboard, then we can go to new dashboard. So in this case, I am going to import a dashboard. Okay. Click on import dashboard. And here we need to provide the, there are some, every dashboard have similar IDs. Okay. For example, Kubernetes cluster monitoring. So Kubernetes cluster monitoring have a similar ID or unique ID. So next one is Kubernetes node health. So similar thing, there is a unique ID there. So we need to provide the ID here. Okay. So if you didn't know the ID, then go to Grafana and we can search on there. There we will get the specific ID. Okay, as per the requirement. So here I am providing like 12740. I don't know if that is related to Kubernetes or not. You can load. Load. Yes, see, I loaded that ID, okay, like 62 something. So this is that ID is for Kubernetes cluster Prometheus. That's the ID. I mean import ID. Sorry, the dashboard ID. So we specify I need that Kubernetes cluster dashboard. Okay, so we need to provide that data source. Okay, as of now, this Grafana doesn't have any data source. Okay, so here we need to mention the data source. So we can go with the Prometheus because in this case, we installed Prometheus and Grafana in the same Kubernetes cluster. So it will take that data from the default, I mean the Prometheus. Okay, so import, choose the data source. When ankle which is duplicated and will stop working in future use of Grafana. Okay, so see, now it's working. Number of node. In my case, how many numbers of node I have? I'll show you. kubectl get node. See, 2 node I have, right? So the 2, it will display here. Yes, it's already displayed. Number of node 2. And pod running. 13 pods are running in my cluster. That is for that Prometheus and Grafana. Because there are a lot of pods are running in between, like C, kubectl, get pod, namespace, Prometheus. EUS. See how many ports are 1, 2, 3, 4, 5, 6, 7. 7 for this specific Kubernetes application, and the rest of them are specific for the master part. There is some ports running on master part. Okay, so it's totally 13 ports running in this cluster. So there are a lot of things are pending. Content running is 19, and here we can specify like specific node only getting the data from the single node. Like if we have a lot of nodes, then we can like filtering everything here. So I am quickly go to onboard one more dashboard. Okay, like 3.1. I will check what 3.1.99. No, that is for the Jenkins, different ID. Kubernetes health monitoring Grafana ID. So we can copy the data board, I mean the Grafana ID from here. Okay, official Grafana Labs website. So I'm copying the ID and go to import dashboard, paste it here and load. See Kubernetes cluster health. So this will load that ID, and here we need to provide Prometheus data source, configuring node data source. being paid by someone else. Yeah, I will check with the pod health. Okay. So how to get that ID? Here we can see import the data, import the dashboard template. Click, copy that ID and open no import dashboard, paste here and load. That is for the Kubernetes pod health overview. This is a dashboard we will get. Okay. So choose Prometheus and import. So this is for the red pod actually. That is nothing there. That's why no data will show here. So anyone have any doubt? So similar way we will onboarding, I mean creating the dashboard for specific services. Okay. Within that, I mean, for example, we need to monitoring Kubernetes pod health. So we need to onboard or we need to create a dashboard to specific requirement. Dashboard or folder with the same name or exit. Pod. So anyone have any doubt? All of you.
I think this was a pretty involved topic. Maybe I don't know how much everybody digested it.
This is actually an overview. Okay. In coming section, I will include virtual machine onboarding. So you will get more idea how this workflow, I mean, this monitoring workforce works.
Okay. Okay. Thank you, sir.
Yeah. For the new joiners, like
Understood.
So,
It was a good session. Yeah.
yeah. For example, if I send one task, can you do it?
Yes, can definitely try.
For the
Yes.
same, I will share that documents and everything.
Mhm.
Okay.
Sure.
So
Yeah.
nothing there, just installing Kubernetes, then using Helm package manager, install these things like Prometheus and Grafana, then onboarding any dashboard. Okay, import any dashboard like this. Put that ID and load. Similar thing. Okay. Got it. All of you. Is that fine? This is the overview section. Okay.
Oh, yeah, that's fine. That's fine.
So tomorrow, day before yesterday, I prepared a AI chatbot deployment. Okay, using CI/CD. So tomorrow we can go through that. Okay.
Okay.
Yeah. Then we can wind
Okay,
up.
sir.
Right?
Okay, sir.
Sure. Thank you for the class. Have a good night, everybody. Good morning to Tawfiq, sir.
Yes,
Woke up
yes.
super early today for this.
Yes. Okay, okay. Bye, bye all that.
Bye.